Alright, so this is another problem video that will start with problem 1624, which is very similar to 1623. In a previous video, give structural formulas for the products formed, if any, from the reaction of acetone with each reagent in problem 1623. And so essentially it's the same as problem 1623, except instead of using propanal, we're using acetone. So we've gone from an aldehyde to a ketone. So part A, acetone, sodium borohydride in methanol. This is a reducing agent again, so we will reduce it to the isopropyl alcohol. Part B, acetone plus phenyl magnesium bromide, followed by acid with an acidic aqueous workup. This is a Grignard reaction. And so we end up converting our carbonyl to an alcohol and attaching this phenyl ring to the carbonyl carbon, and so we'll produce this product here. Part C, acetone with lithium aluminum hydride, followed by water. Again, this is a reducing agent, so we're just going to reduce our carbonyl to the alcohol. So we'll convert our acetone to isopropyl alcohol again, just like in part A. Part D, we have the ketone reacting with silver oxide with hydroxide. This would be an oxidizing agent that we could, in question 1623, we would convert an aldehyde to a carboxylic acid. But because this is a ketone, there will actually be no reaction. And we can't oxidize this ketone using this reagent. Part E, acetone plus triphenylphosphine ylide. So this will be a Wittig reaction, adding a CH2 onto our carbonyl. And so we would convert acetone to isobutylene. Part F, acetone plus hydrogen on a platinum catalyst. This is a catalytic hydrogenation of the carbonyl. So we'll convert it to isopropyl alcohol again. We'll go ahead and move our paper over here. Part G, acetone plus this 1,2-diol with catalytic acid. This will be an acetal formation. And we'll get a cyclic acetal because we have this diol. Part H, it's another Wittig reaction. In this case, we're adding a different alkyl group. And even though we'd get E and Z isomers, in this case E and Z isomers would be the same, so we only have the one product. Part I, acetone plus this diamino silver reagent. This is a Tollens test again. So the Tollens test doesn't work with ketones, so there'll be no reaction. Part J, acetone plus hydroxylamine. It will form this oxime. Part K, acetone this phenylhydrazine. We will form this phenylhydrazone. Part L, acetone, this cold dilute potassium permanganate, and again this would be an oxidizing agent. If this were an aldehyde, we would oxidize it to the carboxylic acid, but it's not an aldehyde, and so it remains acetone, no reaction. We'll move the paper again. Part M, acetone plus this 1,2-dithiol with catalytic acid will form the cyclic thioacetal. Part N, acetone. We'll begin with our 1,2-dithiol with catalytic acid, followed by Raney nickel and hydrogen gas. So this is a Mazingo reduction, and those Mazingo reductions convert carbonyls to alkyl groups So we'll be converting this carbonyl, this acetone, to propane. And finally, part O. Reacting acetone with MCPBA, the metachloroperoxybenzoic acid. This is a Baeyer-Villiger reaction. And so we would create the methyl ester. That we would insert one of these, an oxygen, in between the carbonyl and one of these methyl groups. So that's it for problem 1624.